Hello, everybody. So, good afternoon, and we will start this webinar with some preliminary notes that we want to share with you all. Inez will join us in a few minutes, okay? And I will start by saying to you that this is, as most of you remember, the third webinar. We'll today focus on the second cycle. So the second cycle here means that we are talking about students between 9, 10, and 12 years old. So it's the second cycle in Portugal. And so what we will discuss today is following the two previous webinars, in particular the last one in which we were discussing what you usually do and how we teach fundamental computer science skills to very young kids. Okay, so in the last webinar, as you remember, we were talking about the first cycle. So students with ages between 6 and 9 years old. And so today, continuing exactly our methodology and sharing with you our methodology, we will focus on the second cycle, as I was saying to you. Okay. So, okay, so just to remember you that in the Cisco Networking Academy platform, we are always updating information, okay, not only related with webinars, but also with blended mobilities that we are executing almost in parallel of everything that we are also sharing with you on these webinars. And every time we have one of these sessions, we then typically a few days after the session itself, we would hear some things like questionnaires that we are asking you to fill in order to get your feedback with respect with all these sessions that we are preparing for you. Also the videos, okay, that are available, that become available after the sessions in YouTube, and you have here the links for just one single video or two videos, because sometimes we divide these in two parts. We have already here everything related with the first one, the innovative education and digital era. Then we have also for the last one, the first cycle. Okay, so where you can find the questionnaire, you can also find the video of the session. And today we'll have here also for the session today, we'll have in the next few days also the videos available here, and together with a questionnaire that we will ask you to fill right after this session today. Okay, so please don't forget to come here from time to time and to see what's happening here in this platform. At the same time, I just want to remember you that the next webinar will be next week, okay, in May 11. It will be focused on the Python, okay, and so it will be a brief course in Python, and that corresponds to the third cycle, okay. So following all this methodology that we are explaining to you, so when we go to the third cycle and when we are talking about students with ages between 12 and 15, we start using an object-oriented language like Python, and that's precisely why this fourth webinar is focused on that. Okay.
Just a note, Luis.
Yeah.
May 11 is a Thursday, not a Wednesday.
Oh yeah, you're right. You're right. Yeah. So until now, these webinars were on Wednesdays.
Yeah, but on the
But
Ornet Academy, it's written Wednesday, and it should be Thursday.
You're right. Yeah, you're right. So here, yeah, it's
It's
incorrect.
next
Yeah,
Thursday.
next Thursday. That's correct. So it will be updated right now. Okay. Thank you, Ines.
You're welcome. So I'm gonna share my screen. Okay. So please confirm that you see the slides moving.
Yes, we are
Yeah.
seeing
Okay.
everything
Okay.
correctly.
Okay. Have you explained this part?
No. That's up to you. So talk about the synopsis. But if you want me, I can introduce everything that we will discuss.
Someone raised the hand, I think.
No. I think that it was just to say that everything is okay, and so that everybody is seeing the slides correctly.
Okay, great. Thank you. All right, guys. So today we'll cover several topics. And we are going to begin with lists and functions on lists. Then we will talk about a specific higher order function that's very useful, particularly in programming. We will then talk about an operation on lists, which consists of pairing lists. Then we'll take a quick break, and when we come back, we will talk about dictionaries and graphs. So the break may be moved before part 3. We are not sure yet, but it should happen like in the middle of the webinar, okay? So let's get started. All right. So first, lists and functions on lists. You may not have noticed, but in the previous webinars, we have already been working with lists, okay? So for instance, what is a binary code? When you see a binary code like 10010, that is basically a list of zeros and ones, right? And we've known since we were kids that a word is a list of letters. For instance, the word cat is the list of letters C, A, and T. We also know intuitively that a queue is a list of people. A text is a list of sentences, and so on. So lists are basically everywhere, and they're one of the most important data structures for us to model knowledge. And yeah, because basically it allows us to represent elements in an orderly manner. Now, a list is not the same thing as a set in mathematics, okay? We're talking about different things. For instance, in a list, the order by which the elements appear is important, and the number of times they appear is important too. For instance, the lists 5143 and 5134 are not the same because 3 and 4 are in different positions. And these lists are also distinct from the list 51134, okay? Because the last one has 2 ones and the other ones only have 1 1. Saying 1 1 is a bit weird, but you know. And how do we type a list in Haskell? Well, we use the left bracket to start the list, and then we use commas to separate the elements, and we end the list by writing a right bracket. This is like the way we tell the computer, hey, we are going to work with a list that starts here and ends here, and the elements are separated by commas, so the computer doesn't get confused. So now we're just going to do a little activity, okay? And I'm going to switch the window that I'm sharing, okay?
And just to remember you, so every time we are now looking and showing you these materials in Jupyter notebooks, most of the times we are talking about what we call the SME plugged classes. Okay, so it's where we are not only explaining the contents and everything that we are teaching to the students, but at the same time we will show them how we can execute those things in a computer, and using, of course, a programming language, which in this case is Haskell.
Yeah, and you will have access to these Jupyter notebooks after the webinar. And when you are playing with this and trying to solve these exercises, please don't forget to run this first cell, okay? This is a very important cell. And to run a cell, you can click the play button or press the shift and enter at the same time, okay? So I'm going to click this play button to run this cell, and now I am safe and sound. So we'll begin with numeric lists, so lists whose elements are numbers. And our first activity is actually quite simple. So the Fibonacci sequence is a very famous sequence in mathematics that appears throughout nature and in many more places, according to some people. And the first term of the sequence is 1. The second term of the sequence is 1 also. And then each subsequent number is the sum of the two preceding numbers. What does this mean? Well, we start with 1, 1. And then the next one is the sum of 1 and 1. So 1 plus 1 equals 2. Therefore, the third term is a 2. Then we have a 3 because 3 is 2 plus 1. And then we have a 5 because 5 is 3 plus 2. And then we have 8 because 8 is 5 plus 3. Okay, so you just need to sum or to add up the two numbers that appear previously in order to get the following term. All right, so now you can answer these questions in the comments if you want, okay? So the first exercise is very simple. It's just for you to get used to the syntax of lists. So if you haven't forgotten yet, we need to start a list with a left bracket, and we need to end the list with a right bracket, okay? And then we need to separate the elements by commas. So please write in the comments the answer to this first exercise, okay? So please write the list of the first 8 numbers in this sequence, and don't forget to use brackets and commas. And as soon as the first person answers correctly, I will fill this cell. Come on, 10 seconds. You can do it.
Yeah. Yeah, we have already a correct answer.
We do? Okay, I can see the comments. So I'm going to write this, okay? We start with left bracket. Then we have 1, comma 1, comma 2, comma 3, comma 5, comma 8. And now to get the next terms, we need to sum 5 and 8, so 13. And then 8 plus 13 is 21, and we end our list here, okay? So you may wonder what happens if we press the play button here. Well, nothing much will happen. The computer will basically just tell you what you have just written because we haven't transformed this list, okay? We just told computer, hey, here is a list, do you accept it? And the computer is, yeah, okay, I accept that list. That list is 1, 1, 2, 3, 5, 8, 13, 21. I understood what you said, human. Because notice that imagine I forgot this last bracket, okay? So now the list does not end with a bracket. What will happen is that the computer will say, hey, what are you writing, okay? So I don't understand that. So possibly incorrect indentation or mismatched brackets, okay? And that's the case, okay? The brackets must be matched. So the way we write sequences is very important. Now, who can tell me the answer of B? Has anyone written it yet? So we just need to write the first 8 numbers in descending order. Luis, has anyone answered yet? Okay, I see an answer. So
Yes, we have an answer, yes. 2 answers.
Okay, yeah. I was afraid my internet connection was so bad that I wasn't listening to you because I wasn't Okay, so we already have several answers. I don't know if I'm hearing with some delay, but basically, if we write the numbers backwards, that's it. Okay, so we just start in descending order. So we start from the largest number and then we move on to the smallest number. Okay, so congratulations, you got this one right. Okay, but now suppose that we want to compute the sum of all these 8 numbers. Okay, so there is a function that allows us to do just that. And what is a function? Well, basically, a function is like a rule that assigns a certain input, a certain output. So it's like a robot, you know? So what this function sum does is it takes a list of numbers and it computes its sum. Okay, so it just adds up all the numbers in the list. And how do we apply a function to an object, to a list in this case? So we start, okay, I'm going to zoom this because I think this is more perceptible.
Yeah, that's fine. That's fine.
Okay, so we start with the list. And then we kind of type an arrow, which is just a vertical bar and the greater than symbol, okay? And then we type the transformation or the function that we are going to apply, okay? So this is just a transformation. It's like you are shooting an arrow that's going to do something and transform your input, okay? So what happens when I run this cell? Well, when I run this cell, we are going to get the number 54, okay? And if we compare, let's see if it's right. So if I do 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21, I should get 54, okay? So basically this transformation, when we applied it, it computed the sum of this list, which is 54, okay? So sum is a very important transformation. Okay, now let's look at some other transformations, okay? We have here other transformations, namely maximum and length, all right? So suppose I have a list, say I have the list 8, 1, 2, 9, 2, 8, 7, okay? And I want to know what is the greatest number in this list, okay? What's the greatest number? So I'm going to type my little arrow and I'm going to write maximum. Okay, so I'm asking the computer to return the maximum value of this list. And what should the answer be? Please tell me in the comments. So when I press the play button, what will the answer be?
Yeah, we already have
9, exactly. Okay. 9,
answers. Yeah.
because 9 is the greatest value that appears on this list. And then we also have another function called length. So suppose I want to know how many elements this list has. So I use the function length. It returns the number of elements in the list. So now when I press the play button, what will the answer be? How many elements does this list
Correct.
have? We already have correct answer? Okay,
Yes.
so
Yeah.
7
Several.
elements.
Yeah.
Okay. Yeah, for some reason I cannot see the comments.
Yeah, but we have 7, 7, 7.
Okay, cool, great.
And one not right. Yeah, we are talking about a number, okay, and not a list. Okay. So it's different to write 7 and list with 7 as an element. Okay.
Yeah, first we will only work with functions that transform lists in numbers. Okay, so we have a list of numbers, then we compute the sum, and then we get a number. Okay, so a number is not a list. These are different types of objects. Very well. Now we are going to solve some basic problems using some of these functions. Are you ready? So the first problem is the following. Charles went to a restaurant and he ordered a hamburger for 5 euros, a large soda for 2 euros, a small coffee for 1 euro, and a chocolate brownie for 2 euros. So how much did he pay? What instruction should we write here in order for the computer to calculate how much Charles paid? So observe that this is the list with the prices of the products, okay? So what should I write here? Exactly, I should write sum, okay? So I put the arrow and then I put sum and I get 10. Okay, so when I ask you this, you should not you should not give the answer. You should tell me what I should write to get the answer, because I'm lazy and I don't want to think. I want the computer to tell me the answer. Okay, that's what programming is about. It's like we're lazy and we want the computer to do the hard work. All right. Now I'm using this list, okay? We are always going to use list and transformation. So if I want to know how many products Charles bought, what should I write? What transformation should I apply? So look here, we have sum, maximum, and length.
Yeah.
Okay, so we already have a correct answer. So it's length because we want to know the number of elements on this list. The answer is 4 and it's correct. So Charles bought 4 products. Very good. Now, what should I write if I want the price of the most expensive item? And this time I want you to write the full instruction. Okay, so I want you to tell me what I should write in this cell. And I'm gonna show you so we have sum, maximum, and length. All right. And this time we want to know the price of the most expensive item. And we already have the right answers, okay? So I'm just gonna copy this and write maximum. That's correct. And it's gonna tell me 5. And it's indeed the answer, so the most expensive product was 5. Now, you may be wondering, but Ines, why bother having so much work if those answers are obvious? I mean, I can simply look at the list and see that the maximum value is 5. So why bother applying these silly transformations? Well, but imagine we have like this huge list of numbers, okay? And we want to know how many numbers it has. Can anyone tell me the answer? By using this, by looking at the list, can anyone tell me how many numbers does it have? So I'm going to zoom out a little. It's not obvious, right? There are a lot of numbers. So what instruction should I write in order for the computer to give me the answer? Okay.
One correct
so
answer.
We already have a right answer. We indeed, in fact, we want to know how many elements this list has. So we are going to apply function length, and the answer is going to be 200. Okay, and notice that the computer was really fast, although this is a big list. Okay, so computers are really fast at applying functions, at doing stuff, if we write them in an efficient manner, of course. And what if I want to know the sum of the numbers in this list? So what should I write here? Exactly. So now if I want the sum, I apply function sum, and the answer is going to be this really big number here, okay? And again, the computer was like super fast. Very good. Okay, now we are going to, okay, so maybe I'm just going to, okay, whatever. We'll stay here. I don't want to switch to the slides. So now we are going to work with new transformations, okay, new functions. And this time these functions will not return a number. They will return a list, okay? So let's try to figure out what these transformations do. So I want to test your reading capacities, okay? Okay, so it may be this list. So what do you think will happen if I ask the computer to sort this list? What do you think will be the answer? I'll just wait a bit for someone to type it. What will be the answer? So when I click play, what will the computer tell me? I'm asking it to return a list with the elements in ascending order. Very good. Okay, so we got an answer.
Right.
It's going to be 0, 1, 2, 3, 8, 9, 9, 9, 10. Exactly. Good. Now, who can tell me what the result of reverse will be? Okay, so this time the elements of the list will appear in reverse order, so backwards. Okay, the elements will appear in the reverse order. What do you think the answer will be? Okay, what do you think the answer will be? So I'm talking about this 991239870 list. Okay, we got an answer. Very good. Exactly. So the last number was 0, so now the first number will be 0, and then 10, and then 10, and then 8 will move here. So we are just typing the elements, the numbers in the list backwards. Okay? Now, finally, what do you think the result of nub will be? Okay, so now we're here. Nub returns a list with all the duplicates removed. This means that if some number is repeated, then it's not going to appear on the list. Okay? So what will happen is the following. I start with a 9 and then I have another 9, but 9 has already appeared on the list, so I'm not going to include it. 1 will appear, 2 will appear, 3 will appear, and this 9 is not gonna show up because it has already appeared before. Then we have 8 and 10 and 0, so the list will be precisely 9, 1, 2, 3, 8, 10, 0, okay? So very well. All right, now that you understand how sort, reverse, and nub work, let's use them to solve some more problems regarding Charles' order at the restaurant. So what instruction should I write to sort the prices in ascending order? Okay, so recall the list with the prices of the products. I'm going to type it here again. So 5, 2, 1, 2. Now, what transformation should I apply if I want to get the prices in ascending order? Okay, very well. So let's look at our list here. Sort, reverse, or nub. Well, it's going to be sort. I want to sort it, so I just write sort, and it will write the prices in ascending order. Very good. And now if I want to reverse, what should I write? Well, this is actually also obvious, okay, because we literally have a function called reverse. So let's reverse the list, baby. Okay, so we have 2, 1, 2, 5, and the list appears backwards. All right, and now we know that actually on that day the restaurant had a special offer. So they said, if you buy two products with the same price, you only pay for one of them. So what is the list with the prices of the items that Charles actually paid for? What instruction should I write? What function should I apply to this list? So if you buy two products with the same price, you only pay for one of them. Exactly, it's nub, okay? So with nub, we are going to remove the last two because it already appeared on the list, and the answer is 5, 2, 1. Okay, very good. Great. Now, for you not to think, oh, this is silly and it's so easy, what should we do if we want to sort the numbers of this list in ascending order? What should I write here? Okay, we have a correct answer. If you want to sort the numbers, we write sort. And bam, the list is going to appear sorted, starting with the smallest number and ending with the greatest number. Now, it's easy, for instance, after we sort the list, to know what is the minimum value, which is 55, and the maximum value, which is 1,351,367. But if you look at this list and I ask you, hey, what is the minimum value? What's the maximum value? You don't know. So we really need a computer to work with lists that are huge and have lots of numbers. Now, so far, we have just applied one function after our little arrow, okay? So we have applied sort or nub or reverse or sum or maximum or length. But true power is achieved when we compose functions. So when we apply one function after another. For instance, imagine we want to compute the sum of all the distinct numbers in this list. 3, 2, 7, 1, 7, 2, 4. So I want to know the sum, but I only want to add up the distinct numbers. I don't want to add up repeated numbers. So what do I do? Well, first, I need to get rid of repeated numbers. And in order to get a list with only distinct numbers, okay, I need to apply nub. If I apply nub, I get a list with no repeated numbers, right? But now I want to know the sum of this list. So I could do, I could just copy this one and apply sum. And the answer would be 17. But I can do it all at the same time by saying, okay, computer, please, first you are going to eliminate repeated elements, and then you are going to sum the resulting list. And the answer is going to be 17 too. Okay, so the goal here and the important thing here is that we can apply functions one after the other. Okay, we can successively apply functions to do more complex stuff. Okay, so basically what happened here was, so we had a list of numbers and then we applied nub to get the list of numbers but without repeated elements, and then we applied function sum to get a number. So after we compose these two functions, nub and sum, okay, we get a function. So the composition of these two functions is again a function, okay, that takes a list of numbers as input and outputs a number. Good. So I know you are writing some questions in the comments, and that's great. We will answer them in the end of part 1, okay? Just not to interrupt but yeah, feel free to ask the questions you want, but we will only answer them when we finish part 1 of this webinar, okay?
Yeah, Inez, an important thing is to answer to this question that Helen is putting here. So when do you introduce concept of a variable? So Helen, it is important for you to notice that in this language and in functional paradigm, usually you use a variable, but in a different way than when it is used in, for instance, imperative languages like C or like Python or whatever. But Ines can show you, for instance, that you can use a variable that will identify a specific element or object that we are dealing with. For example, we
are going to use variables in a few minutes, okay? So I think it's better to show you then. All right?
Yeah.
We are going to use variables, but not now.
One important thing, Ellen, is that the variables here are not mutable. Okay, so we are not talking about variables that can then change the value that is storing. It's more a label, okay, that is used to associate something, and then you will use that label in order to avoid using the object itself or the element itself, you know? So it's not a variable as it is used in the
better.
Python. Yeah, sorry, Inês.
Yeah, and you will understand better what we mean by this later on this webinar. But Luis, feel free to reply in the comments
Yeah. I will
to
reply. No problem. No problem.
yeah,
Yes. Yes,
it's
they
very
are.
interesting, and it's very common to have these kind of questions because the function paradigm is different from the imperative or object-oriented paradigm.
Yeah.
So it's okay if you have doubts. It's completely fine.
Yeah, just a final comment. Just a final comment related to this. You should think that everything is a flow. Okay, everything is a data flow. Okay, so you have something, then you transform the something, and then you have another element that you will work with. Okay, and then you do the composition of transformations, like Inez was showing you before, and that's what you have, okay, when you are talking about the functional paradigm. And we believe, and that's why we are using Haskell in these first ages, is that it's more natural to introduce programming concepts by using the functional paradigm, okay? Because you can't forget that students are already familiar or should be familiar with some mathematical objects and mathematical transformations, okay, like for instance adding a number or things like that, okay. And so that's precisely what we are trying to use here, is that particular knowledge that they are acquiring in order to introduce them to some programming concepts as well.
Thank you, Luis. Okay, so now we will work with all these functions. Okay, so recall that sum returns the sum of all numbers in the list, maximum returns the greatest element in the list, length returns the number of elements in the list, sort returns any list with the elements in ascending order, reverse returns a list with the elements in reverse order, and nub returns a new list with all the duplicates removed. Okay, so now we have this big list and we want to know how many distinct elements it has. So what transformation should I apply? One is not sufficient, I need two transformations. So what is this first transformation? If I want to know how many distinct elements the list has. Exactly, so first we apply nub. And when we apply nub, we get a list with all the distinct elements. But now I want to count how many they are. So what other transformation should I apply? So in order to count, I want to know the number of elements, okay? So I'm going to use length, okay? So nub and then length, because this tells me the number of elements that this list, okay, after applying nub, this list has. So I'm going to play and it says it's 195. So before the list had 200 elements, but if we eliminate distinct elements, we get 195 elements. And if I want to know the sum of all the distinct elements in this list, what should I write? So again, I only want to work with distinct elements, and then I want a sum. Okay, we got a correct answer. So I apply nub in order to get rid of repeated elements, and then I apply sum. Very good, and we get our answer. Okay. And now this is a little different. I want you to sort the elements of this list in descending order. So sort writes the elements in increasing order, in ascending order, okay, from the smallest one to the greatest one. But now I want the opposite, okay? I want the largest element first and the smallest element last. Okay, we got the right answer. Very good. So if we sort this list, we get the list in ascending order. But now we need to apply another transformation. Okay, we need to reverse it. Because if you have something in ascending order and you reverse it, it becomes in descending order, correct? And the answer is going to be precisely this. So now the largest number appears in the first place and the smallest number appears in the last place. Okay, so now to finish, we have been working with numbers, but we can also work with characters and strings, which are other data types. So if when we want to type a character, which can be like a letter, a punctuation mark, or some symbol, we need to write one quotation mark, okay? So for instance, if I want to write the character A, I write this. Because if I want to write the character A and I just type A, it is not gonna like it, okay? Because it will think that A is a variable, but I'm not assigning any variable to this, okay? So it doesn't make sense. So when you want to type a character, we really need to use one quotation mark, okay? And here is the same. So these are other types of other data types. And then we also have strings when we want to write words or sentences. And in that case, we use two quotation marks. Okay, so if I want to write the word banana, then I use quotation marks, two quotation marks. All right, because again, if I just type banana, the computer is going to say, I don't know what that is, because it doesn't know this is a word. It thinks that this is a variable, but it has no value, so it doesn't make sense. And the same thing happens when we want to type a sentence, okay? We need to use double quotation marks in the beginning and in the end of the sentence. So if I run this cell, okay, we are good. And now we are going to apply the previous transformations to strings. And why can't we do that? Well, because a string is basically just a list of characters, all right? So the string hello world is the same as the list that consists of the characters in hello world. It starts with H, then we have ELLO space, okay? So the character space also needs is also a character, and then we have the other letters, and finally the exclamation mark. And notice that when I execute this cell, it is going to return this string. Okay, so the computer is telling us that a list of characters and the string are exactly the same thing. And now we can apply some of the previous functions to strings. Okay, let's do some exercises. So the longest word in the English dictionary is pneumono-ultramicroscopic silicovolcanoconiosis. I want to know how many letters this word has. So I need to count the elements, so the number of characters in this string. So this is a list of characters, and I want to know how many characters it has. So what should I write here? What function do you think I should apply? So I want to know how big exactly is function length, because I want to know how big this word is. I want to count the number of characters, and it's going to tell me 45. And what if I want to write this word backwards? What should I type? Do we have answers? Okay,
No,
write the
not yet.
word backwards.
Yeah, okay.
Okay, we have now. Yeah, exactly. It's reverse. So we want to reverse the order of the letters. And we also get this very long, weird word. Okay, very good. Next, we want to order the letters of this word alphabetically. What should I write? We want to order it, okay? So from exactly, it's going to be sort, okay? So it's gonna write the A first and V last, okay? Because it will order the characters in the letters in the word alphabetically, okay? Good. And if we eliminate repeated letters, what word do we get? What function should I write? Exactly, nub. So we are going to remove all repeated letters and we get a way smaller word. And if I want to know how many letters this word has, I can compose these two transformations. Okay, so this is basically this small word here, and I want to know how many letters it has. So how many distinct letters are in this big word? So what other transformation should I write here? I want to count the number of letters.
Correct.
Length, exactly. Okay, length. And we get 14. So like we have a really big word with 45 letters, but most of them are repeated. So we end up with only 14 letters, okay? And we can confirm it. So if I take this word here and I apply length, the answer is going to be 14. Good. So this was just for you to kind of understand some of the data types you work with, like numbers and characters and strings, and also some functions that we can apply to transform these objects. Okay, so we have reached the end of part one. I'm going to stop sharing my screen, and now if you have some question, you can write it in the comments or raise your hand and we will allow you to speak.
Okay, if there is no questions, I just want to highlight one thing. Okay, so the importance of this first part was for you to see, okay, and to think that everything is related with the the use of a language. Okay, so of course that everything that was written in text for, related with questions that you Ines was then answering, okay, by using Haskell, you was something that you see the English sentence and then you translate that same sentence in somehow to a different language that will answer the question. Okay, and so that's precisely why we are always talking about putting the teaching of a programming language between what you are learning in math, which is also a language, and what you are learning when you are learning your mother language. Okay, so language, language, language. It's precisely what we are talking about, and we are just trying to figure out how we can translate some of the things that we are dealing with from one language to another. Okay, of course, the language that we are using when we are programming in Haskell is more related with the math language. Okay, but it's a language, and that's the most important thing.
Okay, so I think we can move to part two, am I right?
Yes, we can jump to part two. Yeah.
Okay, so we are going to learn a new function, and this time is a higher order function, okay? Which is the map function. So in order for me not to be constantly switching from the PowerPoint to Jupyter, I will run Jupyter in the end if there is time, okay? Good. All right, so by now you must have noticed that functions occur all the time, okay? So they're really important when we want to transform things, and they happen both inside or outside the computer. So transformations are constantly occurring. It's intuitive. And even when we add two numbers, a transformation occurs. So for instance, when we look at the operation 25 plus 12, we can rewrite this as if we were applying a function to something. But what function are we applying? And what is the initial object? What's the input? What's the function? And what's the output? Well, it's the transformation at 12, okay? So if we want to compute 25 plus 12, we are basically applying the function plus 12 to number 25, and we get an answer of 37, okay? So we have a transformation whose input is number 25, and the output is number 37. Got it? Cool. So let's see another example. Oh, okay. So an important observation is that this function takes a number as input and produces a number as output, okay? So it does not operate on lists of numbers, but on the numbers themselves. So it has nothing to do with the transformation sum. It's a completely different function that consists of summing 12 or adding 12 to a number. Another example. So say we have 11 times 8. Okay? So what is the even transformation here? Well, the multiplication sign is represented by this symbol, which I don't know how to pronounce in English. It's like a star. So the transformation is precisely multiplication by 8. So if you want to compute 11 by 8, if you want to look at this as we want to look at this as applying a asterisk, thank you, function times 8 to number 11. So the input is 11, the function is multiply by 8, and the output is 88. Okay, so 11 times 8 gives 88. Cool. And again, this is a function that takes one number as input and gives another number as output. All right? So now I'm going to ask Luis to launch a poll, and I want you to select the results of these transformations, okay? I'm just going to stop sharing my screen for you to see the poll appearing.
Yeah, the poll was already launched. So I think that you are now seeing the poll in the center of your screens.
Yeah, so I'm just going to share my screen for you to see. Okay, so you see the poll is appearing like here in the screen, and you should close this. Okay, you should close this and open it on the side so you can simultaneously see what I'm sharing and the poll. Okay, so please, you can close it and open it here on the side, and now you just need to select the right answer, okay? And this first activity actually has 3 questions. So if you click the arrows, you can see that it has 3 different questions. So you should answer each one of them by clicking the option you think is correct, okay? So I'm going to share the PowerPoint again. Okay, let me just come back here.
Don't forget to submit your answers. Okay. We already have answers. 9 answers to this.
Okay, and I'm trying to see how many are correct, but my phone is not cooperating. Anyway, so we are going to show the solutions.
Yeah, we already have
so
11
the
answers.
first one is simply 3 times 9, so the answer is 27. Okay, then the next one is 5, and then we multiply it by 10, so we get 50. and then we add 2, so we get 52. And finally, the last one, we have 5, and then we add 2, so we have 7, and then we multiply that by 10. So 7 times 10 is 70. The answer is 70, okay? I believe everybody got it right. Okay, except the last one. So, except the last one. But the first two, everybody got right. So, good job, guys. And you see, this shows that you cannot switch the order of multiplication and addition. Okay, the order matters. It's not commutative. Now, going back to numeric lists, what do we have to do to transform the list 1258 into the list 2369? So suppose that the first list is a list with the prices of some products, and each product got more expensive, okay, and is €1. What's the opposite of cheaper? Well, it costs one more euro,
Expensive.
okay?
It's more expensive.
Yeah,
Yes, more expensive,
more
one
expensive.
euro per item,
Okay,
right?
so what happened to each number when I go from 1258 to 2369? Well, basically, we add 1 to every element, okay? So we want to add 1 to each element of the list, but do you think this transformation will work? Can anybody explain why this transformation will or will not work? Okay, so I think some of you think this will work, but it won't. And the reason is, as I said, so this transformation like +1, +2, times 10, times 8, or whatever, they take a number as input, okay? They take a number as input, but here we do not have a number, we have a list, all right? So it will not work, right? So we need something that allows us to apply this +1 to the whole list, okay, to each individual number, because this will not work. And that's where map comes in, okay? So like the computer will give us an error message if we apply the transformation +1, because it only works on numbers, it does not work on list. That's why recognizing the data type that we are working with is very important. Okay, so we will have to invoke a higher order function called map. Okay, so it's a function far more powerful than those you already know. And it's basically a queen of functions because this map transformation cannot do anything on its own. Okay, so if you write 1258 map, you get an error message. Okay, it doesn't do anything on its own, but it can pick up other functions and apply them to a whole list. Okay, so if we write 1258 and write +1, it won't work, okay, because +1 only operates on numbers. But if we write map +1, it's like we're saying, hey, please take the list 1258 and apply the function +1 to each element, okay? So now we are telling the computer that we want to add 1 to every number on the list, okay? So map does that. It allows us to apply a function to every element of a list, okay? Let's see another example. Okay, so this is basically what I said. So you see, so map +1 means that it's taking the +1 function and applying it to every element on the list. And by the way, it's very important when you teach these kind of things to small kids that you have visual representations. And so kids love our robots and the way we represent them, and they really learn better when they kind of see a function as a robot and not just like super abstract thing that they don't understand. So these robots are actually very important for students to understand what we're doing. So here is the difference. Here is the difference. So the +1 function takes a number as input and outputs a number. The map +1 function works on lists, okay? So it takes a numeric list as input and outputs a numeric list. They are not the same thing. They operate on different things and they give different types of results. Another example, if we have 1, 2, 5, 8, and then we multiply by 2 every element, we get 2, 4, 10, 16. Okay, so we go to each number and we multiply it by 2. Easy, right? I think it's easy. So now it's time to test your understanding. Please, we will launch another poll and we will ask you to answer these 3 questions. So again, you're going to see 3 questions on the poll. Okay, so poll is launched. So first you need to select the result of map times 3. Then map +5 and then map +2. So in this second exercise, we are composing 2 map transformations. So first we apply map +5 and then we apply map +2. Okay. And finally, we want to reverse every word in this last list. Okay, so this exercise is a little more complicated. Let's see how you're doing. Okay, so far we have 10 responses, and I think the first 2 are correct. I think everybody answered correctly the first 2, but the last one, for some reason, I don't think anyone answered correctly. Can you check, Luis?
Uh,
Well, whatever. No, never mind. So I'm just gonna show
yeah,
the
but
solutions, okay?
yeah, but there is at least one, but I really don't know
Oh,
why
okay. So I
it's
don't
not
know.
appearing.
My phone is just showing me some weird things. I don't
Yeah.
know, whatever. So the first one is 30, 27, 24. Everybody got it right. The second one, everybody got right too. And then the last one, we basically go to each word and we reverse the order of the letters. So I is I, then we write like backwards, so it's EKIL, and then we write math backwards, so it's HTAM. Okay? So if there are no questions, we may proceed. And yeah, so this is the end of part 2. So before the questions, I can show you this in Jupyter or in Haskell. So I'm gonna share another window and let's go to Jupyter. Okay, so I'm just gonna run this. Yeah, so somebody's saying that, yeah, I in my phone I also saw that. I don't know why, but the answer was the one that I told you. I don't know if there was some problem with selecting the right thing. Anyway, so here you see also when you have 12, 25, and then we apply function +12, we get 37, and then 11, and we apply times 8, we get 88. And then this was the answer of the first poll. Okay, so computer really fast at executing these functions. And then you see that it does give an error if you just take a list and you apply function +1. It does not work, unfortunately. Okay, and this also does not work, so map cannot do anything on its own. But then when we apply function +1 to every element on the list, we get 2, 3, 6, 9. Okay, so it's this where every number is increased by 1. And if we multiply every number, we get this. And finally, the answers, okay, of this last poll, as you can see. So these are the answers of this last poll. Okay? Good. So now it's time for questions.
Yeah, Ambrose, the map function is like, as I was saying, is the queen of functions. Okay, so But and yes, it's like you were saying. So this is a cycle or kind of cycle, okay? Because in an imperative language, typically you are talking about an array. When we are talking about a list, we are talking about an array, for instance. And then you execute a cycle that goes from the first element of the array to the last one. And then the most important thing is that you should apply the same transformation or the same function to each single element. Okay, and so that's precisely what map is doing. But of course, map is doing this in a more elegant way. Okay, so we are talking about lists that contains elements of the same type. Okay, we are talking about numbers, or we are talking about characters, or we're talking about strings, or so on. And then the most important thing is that we are applying the same function to all the elements of a specific list. Okay, and here everything is very natural, straightforward, because you are following the rules. But when you are talking about other languages in an imperative paradigm, you may do things that are not correct, but the compiler will accept that. And that's why you have typically lots of bugs. Okay, lots of bugs in your program.
Somebody raised the hand and I allow the mic.
Oh yeah.
So you can ask a question if you want. Okay, so you may also type it in the comments if you prefer.
Yeah.
Do we move on? Should we move on?
Yeah, but Ogun Remy, I don't know if you have any question. I don't know if you are. I don't know if you are having some problem, but you can chat, as Ines was saying. You can chat if you prefer.
You hear me now? Hello, can
Okay,
you hear
we
me?
are listening now.
Yeah.
Okay.
Please, my question is this. Please, I came late to the class. I'm Ogunremi Olatunde. I'm came late to the class, and I want to have a video of this lecture, the full video of this class, so I can be able to sit down and work on it. Please, I'm interested. Please.
Yes.
Thank you.
Yeah. After this session, okay, in the next few days, you'll have the links for the videos available in the Cisco platform. Okay. So you can just go there and you will see the links for the videos of this session.
All right. Thank you. I will access that. Thank you.
You're welcome.
Thank you. So Luis, we have another question. How do you apply this learning with students? That is, why are they learning this?
Oh, okay. Well, as we said, okay, not only in this webinar, but also in the previous ones. Okay, so we are trying to put all this knowledge, okay, the fundamental of computer science knowledge, and of course, when we are now talking about using Haskell, we are already talking about programming. We are putting all this knowledge on top of the knowledge that students already have or are acquiring. Okay, in particular, everything that they are acquiring, the knowledge they are acquiring in when they are learning the mother language and when they are learning math. Okay, and so for us, it's important to use this functional paradigm, and in particular, a language like Haskell, because we really think that it's straightforward. And based on our experience, everything is working well, and okay, and students are really understanding all these concepts that are, as you know, the most fundamental and important concepts when we are talking about programming in any language, not only in a functional language like Haskell, but also when we are using Python or we are using C or whatever. Okay, and so we are in fact talking about the fundamental skills when we are talking about programming, and those skills should be built on top of, first of all, the knowledge of the mother language, okay, then the knowledge around the math language, and if they understand those concepts that they are acquiring in these two disciplines well, they will be able to understand also quick and easy a programming language like Haskell, okay? And after that, if they acquire all this knowledge and all these concepts related with data structures and also transformations and so on, they will be able to use any other language like Python, C, or whatever. Okay, that's what we are. That's why we are learning this and teaching this, and that's why we really think that we are doing the right thing based on the experience that we had until now with our students.
Thank you, Luis. So if there are no more questions, I think we should take the break now, because then we are going to talk about pairs and all of that. So it's like I think it makes more sense to take the break now. So
Yep.
we will see you in 15 minutes, okay? So see you in 15 minutes, okay? We'll be back soon. So should we resume the presentation?
Yes. Yes, I think that we should now start with part 3. And we need to
Exactly.
we need to go a little bit more faster in order to finish everything.
Don't worry, I speak fast enough.
Yeah.
Let me just open the PowerPoints. Okay, I'm gonna share my screen.
Yep. Hi everybody, may we start now? The third part. Okay. So let's go for the zip function.
That's right. So we have just seen that we can add numbers, we can multiply numbers, we can subtract numbers, we can divide numbers. So we know a lot of operations that we can do with numbers. But what about lists? Can we sum lists? Can we multiply lists? Well, not exactly, but there are some operations that we can do with lists, namely pairing them, okay? And that's what we are going to talk about now. So probably if you are wearing pants or a jacket, you are wearing a zipper, okay? As in this image. What do you think this has to do with lists? Can anyone see the connection between a zipper and an operation on lists? This is the most difficult question of the whole webinar because it requires some creativity. Okay, combining them, joining, bring things together. Yeah, so basically all of those answers are correct. You see, when we have a zipper, we have a list of teeth on the left side in red, And we have a list of teeth on the right side in green. And what the zipper does is it makes the teeth interlock with each other, pairing them. Okay, so we have a list on the left, a list on the right, and we sort of pair the elements. How exactly do we do that? Well, we are going to suppose that the green list consists of the numbers between 1 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we're going to suppose that the list on the right in red is going to be 10, 20, 30, 40, 50, 60, 70, 80. Okay? So now what happens when we pair these two lists? Well, for instance, there's a missing N there. Tooth number 1 on the left will pair with tooth number 10 on the right. And we will get the pair 1, 10. You see? So 1 will pair with 10. And 2 will pair with 20. And 3 will pair with 30. And so on and so forth. Okay? So we will have these pairs. And how do we write a pair? Well, instead of right-angled bracket, we use a curved bracket, okay? So a parenthesis, a curved bracket in the beginning and in the end. So this is not a list. This is a pair. It is an ordered pair, okay? Okay, so now we have this basic activity just to see if you understood how this pairing happens. So I will ask Luis to please launch the poll, and you need to select the pair of numbers that will not be created by moving the slider, okay?
Okay.
Just to check if your intuition is correct. Okay, so we already have some answers, and all of them are correct. Okay, so it is indeed the pair 222, okay? Because 2 will be paired with 20, not 22, okay? 22 doesn't even appear on the right, so it would really not be possible. Cool. And all the other pairs will be created, okay? So every number will pair with 10 times that number, okay? And now when the pairing is complete, we will have a list of pairs, okay? So we start with two lists, okay? And then when we pair them, we get a list of pairs. 110, 220, 330, 440, 550, 660, 770, and 880. Okay, it's a list, and every element of the list is a pair. So, by the way, how many elements does this list have? Please write in the comments. Extra question for you that just came to my mind. So how many elements? The right answer is 8, not 16, okay? Because we only have 8 pairs, and each element is a pair. So 110, 220, 330, 440, 550, 660, 770, 880, okay? The right answer is 8, only 8 pairs. We have 16 numbers, but the numbers are not the elements of the list. They are the elements of the pairs. The pairs are the elements of the list. So the length of this list is 8. Okay? And in Haskell, there is a built-in function called zip that takes two lists and returns the respective list of pairs. But to simplify the notation, we prefer to use this symbol. that again, I don't know how to pronounce in English, okay, but we define an operator, which is this symbol, to do exactly what zip does, which is pair the sequences. So for instance, when you do 1, 2, 3, and then we zip with 10, 20, 30, we get the list of pairs 1, 10, 2, 20, 3, 30, okay? So this hash, okay, hash. This hash symbol means that we will pair the two lists. It's like the plus operation in math or the division. It's a symbol that indicates an operation, okay? And this is the pairing operation. Thank you for telling me that it's an hash. Okay, so next, Paul. You need to tell us if we pair the first list with the second, we get a list of pairs, and we want to know what pair appears on that list. So this time, only one of the pairs that you are going to see in the options actually appears after we pair these two lists, okay? So please answer the poll. Just gonna wait for some answers. Okay, so only one of them appears on the list. Which one is it? Okay, so we already have some right answers. And the right answer is N pants, because N is the first element of the first list, and pants is the second element of the second list, okay? So when we pair these two lists, we are going to get a pair. The first pair will be precisely N pants, okay? And the full list will be this, okay? So the result of the operation is this list. There's a comma missing here after Joe Pants, but by the way, how many elements does this list have? Please answer me in the comments. So how many elements does this list have? Okay, you got it. 5. Exactly, because we have 5 pairs, okay? Very good. So we can go on. Now, so far, we have seen perfect zippers, okay? We have seen zippers that have the same number of teeth on each side. But what if the slider is broken and it has fewer teeth on one side than on the other? So what if we have like 7 teeth on one side and only 3 teeth on the other? Well, what happens is intuitive. So imagine that we pair the list 1, 2, 3, 4, 5, 6, 7, 8 and the list 10, 20. We are only going to get 2 pairs, okay? Because that's the size of the smallest list. You see, just imagine a zipper, okay? So if you have 8 teeth on one side but only 2 on the other side, you can only pair the first 2 because the slider won't slide the rest because there are no more teeth on the right. Okay, so when we pair these two lists, we only get 2 elements. We only get the first 2 pairs because the second list only has 2 numbers. And what do you think would happen if we only had 1 tooth on the right? What do you think will be the result of this operation? So what if we pair 1, 2, 3, 4, 5, 7, 8 with a list with only number 10? What is the answer? Please write in the comments.
Correct.
Actually, nobody wrote the right answer because you are answering me pairs, but the answer is a list of pairs, okay? So do not forget the brackets, all right? Yeah, not yet. I still haven't had the correct answer. Come on. It's a list of pairs, so it's a list. Okay, now we get the right answer,
correct,
okay?
correct.
Okay, very good. So it's this list, okay? So we have a list and with only the pair 110. The result of pairing two lists is always a list, okay? Do not forget that. It's always a list. And what if there are no teeth on one side? So in that case, the slider can do anything, okay? And this here is the empty list. So it's a list that has literally nothing inside, okay? And this may seem weird, but it's actually important. It's actually an important object in programming. So if we have like 8 teeth on one side, but no teeth on the other side, the slider can't move, it can't do anything. So there will be no pairings because on the right, we have nothing to pair, okay? So the result is the empty list. Cool. Now, we are going to launch another poll just to check if you understood this operation of zipping.
Okay, so you can now write. No, you can now
select the
select
correct
the
answers. Yeah.
Yes. Don't forget that you have two questions in this activity.
Yeah, there are 2 questions. Yeah, note that, okay, so all the answers are correct. Very good. Just note that there exists the empty list, but there does not exist the empty pair, okay? So if you just write the parentheses, that doesn't mean anything, okay? So these are the answers, all right? In particular, the second one is the empty list. It's not a list with an empty pair because empty pairs don't exist, but the empty list does exist, which is a list that has nothing on the inside. Okay. So this is it. Okay. So if you have any questions regarding this zip operation, please tell us in the comments or raise your hand. If not, we are going to see how to apply this pairing operation, because it's natural that you're thinking, what do we use this for? What is this useful for? But it's actually quite useful, as we are about to see. So,
Yeah, let's jump to part 4.
Yeah, but we're good on time. Oh,
yeah.
I could show the Jupyter notebook, but I don't think it's necessary because you already saw the answers. So
yeah, it's not necessary. I think that with the Jupyter we have for this part 4 is enough.
okay, so we continue to part 4. So now we are going to apply, wait, can you see the slides moving? This is sharing some weird, wait, something isn't quite right. I closed, oh my God, what's happening? I don't know what, I messed up. Sorry.
No problem.
You will have the Jupyter link later, yes. Okay, so now we are gonna see how to apply this operation of pairing lists in the context of dictionaries. And we are going to teach you some Portuguese along the way. Yay! Okay, so currently, when you want to translate a word or sentence into another language, you probably use a digital tool like Google Translate. You don't actually use like a dictionary to check the translation. But dictionaries are not old-fashioned, okay? They are still used today, and they are hidden behind applications that we use all the time on our smartphones and computers, okay? Wait. So consider a Portuguese English dictionary. What is a Portuguese English dictionary? Well, it's a dictionary that contains translations from Portuguese words to English words. For instance, the translation of gato in Portuguese is the English word cat. So now you know how to say cat in Portuguese, okay? Gato. And on the computer, as we saw, we use quotation marks to represent words, okay? It's a string. Remember when we talked about characters and strings? So when we represent a word, it's a string, so we need to use quotation marks. Cool. And you know, quotation marks allow us to distinguish a thing from the word that represents that thing. Okay, so there's a difference between a thing and a representation of the thing. When we are using the computer, we are representing things. We are not working with the things themselves. The same way when I write a 9, I am representing number 9. But 9 is a concept, an idea. And the same applies to this. You know, Porto is a city, okay? It's a big city with thousands of inhabitants, but Porto with the quotation marks is a word, is a 5-letter word. So we are talking about a thing, Porto, and the representation of that thing, Porto. Okay? Yeah. In order for the computer to know what are we talking about. So suppose we have this list of Portuguese words, and then we have the list with our English translations. Okay? What do you think we should do to relate these two lists and create a mini dictionary? We have these two lists. What do you think we should do to them? Tell me in the comments. I want to know.
Yes.
Exactly. Yes. So we can zip them together. We can pair them because that way we will establish a correspondence between the word in Portuguese and the word in English and the translation in English. Okay. So we are kind of gonna zip it up. Okay. And we will get this. Okay, so the first pair, gato, cat, means that the translation of the word gato in Portuguese is cat in English. Casa is house, ovo means egg, and raposa means fox. Okay? So how many elements does this list have? How many elements are in this list? 4, exactly.
Right.
Great. Okay, so when we are teaching this, or if you eventually are going to teach this, you can ask, what is being represented by the expression English # Portuguese. Okay, so you see, now we are calling, and I can actually show you the Jupyter, because now we are actually dealing with variables, in case you haven't noticed. Okay, so okay, so here I'm calling Portuguese to this list of words, okay? When I run the cell, nothing happens because the computer simply it simply understood that we are calling Portuguese to this list of words. So when I write Portuguese, the answer is going to be the list of words because we defined Portuguese to be this list of Portuguese words. Okay? And the same happens with English. So we are going to call English to this second list with the English words. And now if I write English, and I click the play button, it's gonna tell me, okay, English is that list. So it's just a way for us to give names to lists in order for not having to write the whole lists all the time, because that's boring and we're lazy, okay?
Please note that Inês was executing the cells, okay? So the cell in which we were using, associating Portuguese to that particular list, then Inês was executing the cell before the other cell in which you see the Portuguese variable, okay?
Yeah, you always need to execute the cell when you are defining a variable. And now we can see that if we zip Portuguese with English, okay, so we are actually zipping these two lists together, okay? And we get this list of pairs with the words in Portuguese and their translations in English, okay? Now, what happens if I do English and I zip it with Portuguese? This is basically a dictionary between Portuguese and English. So you have a word in Portuguese and you have the translation in English. What if I do English and then Portuguese? What dictionary does this represent? Exactly, it is an English to Portuguese dictionary. Okay, so the English words will appear first. Okay, the English words appear first and their translations in Portuguese appear second. All right, whereas in Portuguese English, the order is reversed. So first you have Portuguese and then English. And you can also take the opportunity to highlight the fact that the zip operation is not commutative, which means that the order by which we zip lists matters, and it's also not associative, okay? So the order by which we pair the pairings matters. I'm gonna explain this with an example, but this is very good for you to relate to mathematics, because in mathematics they learned that addition and multiplication are commutative and associative, but for instance division is not commutative. 2 divided by 4 is not the same as 4 divided by 2, right? The same thing happens with pairings. So now I am going to create these 3 lists, okay, which I'm going to call A, B, and C, because I have no creativity for naming lists. All right. So I executed this cell, and now the computer knows that I'm calling A to the list 1, 2, 3. I'm calling B to the list 5, 4, 6, 4, 5, 6 actually. And I'm calling C to the list 7, 8, 9. Now, what happens if I zip A and B? Well, I'm going to get this list 1, 4, 2, 5, 3, 6. But if I pair B with A, I'm going to get a different list. What list will I get if I pair B with A? Can anyone write in the comments? Exactly, so it's going to be 4, 1, 5, 2, 6, 3. You see? So A hash B is not equal to B hash A. It can be equal, that can happen, but in general, they are not equal, okay? They can be equal, but not necessarily. And the same thing happens with this. So I have a challenge for you, which is writing in the comments the results of this thing. So A hash B hash C. This is not easy, but I will be very happy and congratulate you if you can do this. I'll just wait a few more seconds before revealing the answer.
Mhm. Okay.
Okay. Yeah. We got an answer. So, exactly as Jonathan and Eduardo wrote, so if we pair B and C, we get this 4, 7, 5, 8, 6, 9. Okay, if we pair B and C. And then if we join A in the beginning, we are going to have the elements of A as the first element of the pair. So 1, 2, 3. Now, question for you. How many elements are there in this list? How many elements?
Right.
Exactly, 3, okay? And we can confirm this by writing length, okay? So the length of this list is 3. Very well. And you see, if I do A, B, C, so if I first zip A, B, and then I zip it with C, we do not have the same list, okay? So the first element here is a pair, okay? Pair. Whereas the first element here is a number, okay? So these are different lists, all right? So with multiplication and addition, these operations of multiplication and addition are associative, but this is not. So when kids are learning the associativity and commutativity, you can actually show them this computational example for them to be aware that there are operations which are not associative, okay? Okay, I guess I'll just switch to the PowerPoint. Um, okay, so can you see the slides moving? Yeah.
Yes.
Oh,
Yeah.
okay. Okay, so we saw this. Okay, all right. So now we have a poll for you. Okay, so Louise will launch this poll and you will have 3 questions to answer. We'll just wait a few more seconds. All right, so we already have some answers. So this mini dictionary has 6 pairs of meanings, okay? So it's the length of this list, the number of elements is 6. But if you pay attention, you can see that there are only 5 different words in English, okay? Cat, hag, fox, house, and residence. 5 different words in English. And we also have only 5 different words in Portuguese, okay? Felino, gato, ovo, raposo, casa. So we have some repetitions here. And this makes sense, because words may have more than one meaning. The English word cat has 2 meanings in Portuguese. It can mean gato or felino, okay? So now, how can we represent this information on a computer? So if a word has more than one meaning, how should we represent it? So we can represent each pair of words, okay, by an arrow. And we can map the English word to the Portuguese words that represent them. And you see, for instance, the word cat has 2 arrows leaving it, okay? One arrow goes to gato and the other arrow goes to felino. So we have 2 meanings, okay? We have 2 meanings. And what we want to do is we want to group, to collect all the meanings in the same space. So we want to group different meanings of the same English word. And the way we're going to do that is we are going to create a list with all the meanings of the word. Okay? So for instance, cat, you can see, so before cat had two meanings, and we're going to form a list, not a pair, okay, a list with these two meanings. That's it. Okay, so the word cat is going to be paired with the list cat flinu, and then we also have lists with a single element for the other words. Okay, so we can map a word to its different meanings by creating a pair whose first element is the word and the second element is a list of meanings. Even if the word has just one meaning, we still create a list, okay? And we have a function that we call collect to do that. So it collects all the meanings of a word into a single list, okay? So, okay, so I'm going to show you this in Jupyter for you to understand better. Okay, so you see, I'm calling this dictionary dict. Okay, so I execute the cell, and you can see this has only pairs. Okay, so we have like cat flino, cat gato, egg ovo, etc. Okay, and if I apply the function collect, I'm going to get a list whose first element is the English word and the second element is a list with all its possible meanings. Okay? A word and then a list with the possible meanings. A word and then a list with the possible meanings, and so on. So the first element is a word, the second element of the pair is a list of meanings. Okay, so now we are going to test your comprehension and by launching a poll.
Poll number 12, right?
Exactly. Okay, so this poll, we want you to identify the list that represents the information registered here. It's not the diagram on the right, it's the diagram on the left. Sorry for the typo. Already have some answers. Okay, so as I've just shown you, yeah, you have it's this list, option 3, okay? So we have a word and then the list of meanings. Okay? Don't forget, when we apply collect, we get a list whose elements are pairs, and the first component of the pair is a word, the second component is a list with the different meanings. Okay. Now we have another exercise for you, okay? So consider now a more interesting dictionary which has words in the language of elves and their translations in English, okay? So now we have Elvish dictionary, which is the language of elves, with some words, and we have the translations in English, okay? So now we want you to select the correct answer to the following questions, and I will ask Luis to launch the poll.
Yeah, number 13.
Yeah.
Okay.
And I will put the dictionaries here so you can see the words. Okay, we have an answer. Let's just wait a few more seconds. Okay, so as we don't have much time, I will reveal the answer in Jupyter. So I'm going to share a different window. Okay, so here we have our dictionaries, Elvish and English. And now if we collect these Elvish paired with English, we get this answer, okay? So answer number 1 was the right one. 70% of you got it right. You see, it's the Elvish words appear first and then the list of meanings appear second, okay? And then we want to know what's the length of this. So if we do Elvish, and then we collect it, okay, you can see that we have a list with 4, okay, with 4 elements, because the words are all distinct, okay, the words are all distinct. So when we zip a thing with ourselves, and the element doesn't have repeated elements, we are going to get the length of the original lists. Okay? So it's, if you have questions about these apart dictionaries, please write them in the comments or raise your hand as you prefer. And then we are going to move on to the last part.
Yes. Well, an important thing for you to notice again is that, as you have seen, we have used 2 data structures. So lists again. So we are talking about lists everywhere, and pairs. Okay. And so you have seen also the one particular example of a dictionary that uses extensively these 2 concepts, okay? And so we'll now do the same thing for another very important data structure that will be the part 5 and last part of this webinar, okay?
So there are no more questions. Okay, so I guess we will move to the last part. And the best one.
Yeah,
It's
the one
the
that
cherry
this
on
is
top
the
of the cake.
preferred data structure of Ines.
And of our students too.
And of our students, yeah, that's right.
Okay, so we're going to talk about graphs. And I have a little challenge for you. So as you may have noticed, we are surrounded by numerous networks and connections. You see, houses are connected by roads, telephone poles are connected by cables, many people are connected through social networks. So there are lots of connections that are established every day, every second, okay? Now, I want you to try and guess what this image represents, okay? So who can guess what this represents? Our students usually give very interesting answers, creative answers. Okay, so stars, maybe, a neural network. What more? Oh, we got a right answer. Internet. Okay. Yeah, I know it kind of looks like neurons indeed, and that's what our students say. They say that this is like the human brain, the activity of the human brain. But yeah, actually, if we zoom in, you can see what we are talking about. Okay, so if we zoom in, you can see these numbers. Okay, and some of them are connected between themselves by a white line. Okay, so this is the graph of the internet. Okay, and what does this mean? So basically, we have several dots that are joined by lines, and each dot represents a distinct IP address, okay? An IP address which is assigned to a device. And then some of these IP addresses are connected and others are not. So these are basically the connections established using the internet, okay? And you see, this is what we call a graph. So with dots that are joined by lines. And this is an undirected graph because you don't have arrows, you have simple lines. But actually, our focus will be on directed graphs. So you see, nowadays, more than 1 billion people have an Instagram account. But how can we organize so much information on our computers? So what is the computational model behind Instagram? For instance, of course, a simplified version of Instagram, of course. So these things are obviously more complex.
Or any other social network, okay? Or any other social
network.
network.
Or any other social network. So what data structure should we use? And you see, so let's focus on this mini Instagram, okay? And where we have arrows between several users. Now, how should we interpret this diagram? You see, so we have an arrow going from Mary to Isabella, which means that Mary follows Isabella. But notice that Isabella doesn't follow Mary because there is no arrow from Isabella to Mary, okay? Only Mary follows Isabella. And so on, okay? So when you have an arrow from A to B, it means that A follows B. Okay? It doesn't necessarily mean that B follows A. Now, to see if you understood this, we are going to launch this first poll, and you should select how many pairs of friends follow each other. So how many pairs of friends are mutual followers? Because on Instagram, you may follow someone that does not follow you back. So Louise will launch a poll. Okay, we already have correct answers in the chat. And now you can answer directly in the poll. Okay, so all of you got it right, exactly. So we have 3 pairs of friends that mutually follow each other. Okay, there are mutual followers. So Mary and Ryan, you can see these arrows in green. Then we have Ryan and Jane, and also Isabella and Peter. Okay, great. And you know, structures of this kind are called graphs. So we have nodes. In this case, nodes are Instagram users, and we have arrows between these nodes. And graphs are one of the most useful data structure for visualizing and representing relationships between things. But what data structure should we use to represent them on a computer? How can we represent them on a computer? There are actually several possibilities, and we're going to explore one of them, which is using pairs. Okay, so whenever we have an arrow, we represent that by a pair. So for instance, we have an arrow that goes from Mary to Ryan. And so we get the pair Mary-Ryan because Mary follows Ryan. But the pair Mary-Jane will not show up on the list because Mary does not follow Jane. There is no arrow going from Mary to Jane. All right? So now I'm going to ask you to look at this slide on the right, and we're going to ask you to identify the pair of friends that is missing from the list, okay? So there is a missing pair. Someone follows someone, and that does not show up. Okay, and we are going to launch a poll for you to select the missing pair. And I recall you that if A follows B, then you have the pair AB. Okay? Mary Isabella means Mary follows Isabella, for instance. Okay, so we already have some answers. That's right. So the missing pair is Peter Isabella. Okay? So this arrow here, you see there's an arrow going from Peter to Isabella. And so that gives us the pair Peter Isabella. All right? Very good. So far we have talked about unlabeled graphs, meaning that we just have like simple arrows, but sometimes we need to add more information to our graphs. Okay, and how do we do that? So consider now these other, so the same social network, the same mini Instagram, okay? What's the difference between this and the last one? So these as the years that a person started following another person. For instance, Mary started following Isabella in 2018, and Mary started to follow Ryan in 2021. You see? So now how can we represent this information on the computer? That's the question. Well, we are still going, so this contains more information than the previous graph. So the previous graph did not have numbers on top of the arrows, okay, it had nothing, but this one does. So using a list, how can we represent this labeled graph on a computer? What would be like, can you write in the comments the example? Oh, no, okay. So basically, what we do is we write a pair. So, for instance, to represent that Mary started following Isabella in 2018, we write the pair Mary Isabella. Okay, so oops, Mary Isabella as a pair, and then the second component of the pair is going to be the year 2018. Then Mary Ryan will be 2021. So we still have a list of pairs, but now each pair as a pair as the first component and a number as the second component. So the first component of the pair tells you that a person follows another, and the second component tells you the year that someone started following another. So now in this poll, you should select the pair that is missing from this list. Okay, so there is someone that follows someone that does not show up here, and you should select who is missing. We already have some answers. I'm just gonna wait a little bit more. Okay, so as you can see, the missing pair is this green one. Peter Isabella 2016, okay? Which means that Peter started following Isabella in 2016. Let's see another example of a graph, a labeled graph. So this is the context. Ryan wants to build a house. And what does this graph mean? For example, this red arrow with number 5 on top tells us two things. That the walls will take 5 weeks to erect, and the roof can only be placed when the walls are finished. So when you have an arrow from A to B, it means that B can only be placed after A. For example, you can only place the doors after you have the walls, and you can only place the floor after you have the walls. Okay, and you can only paint the house after you have the doors, roof, and the floor. Okay, and only after you paint the house, you can live there. All right, And the numbers mean the amount of time that it takes for one thing to be done. Okay? So, for instance, this arrow with number 4 from roof to paint means that the roof takes 4 weeks. The roof takes 4 weeks to be put in the house. Okay? So I will ask Luis to please launch the poll, and we want you to answer these 3 questions by looking at this graph with the construction work. So this exercise is a little more trickier than the previous ones because you need to interpret what the graph is saying. Okay, we already have an answer. Just wait a few more seconds. So we should look for the longest path to node OK.
Don't forget that we are talking about weeks, not days, okay?
Okay, so I think we already have plenty of answers and they're all correct. So how long will it take to build the house? It will take 11 weeks, okay? So we need 5 weeks for the walls to be erected. Then we need 4 weeks to put the roof. And then we need 2 weeks to paint the house. And 5 plus 4 plus 2 gives 11. Okay, now is there any delay if the doors start to be made 2 weeks after the walls? Well, no, because the walls take 5 weeks and the doors only take 1 week, and 2 plus 1 is 3. So there is no delay because the walls already take plenty of time. Okay? And finally, the carpenters want to make the doors as soon as possible and place as soon as they're ready. Can they do that? They can't, because they need to wait for the walls to be put, okay? Because the doors only take 1 week to be made, and placing the doors take also 1 week, but the walls take 5 weeks. So we need to wait. They need to wait. You cannot put a door if you don't have a wall first, right? So this is an interesting exercise to test if the students can interpret correctly what is being asked. Okay, these are the solutions. Now, these graphs whose labels on the arrows are numbers are called weighted graphs. So they are particular examples of labeled graphs. Because a label graph can have any symbol as its label, but weighted graphs can only have numbers as the labels. Okay? And since the labels are numbers, we can do calculations with them. Okay, we can add them, we can multiply them, we can do whatever we want. Well, not whatever we want, but you get it. So here in this map, we have some Portuguese cities and the distance between cities in kilometers. So, for instance, we have this arrow which goes from Porto to Coimbra, and the number is 124. This means that we have to drive 124 kilometers to go from Porto to Coimbra. Okay? And since we have an arrow from Porto to Viseu with the number 127, it means that we need to drive 127 kilometers to go from Porto to Viseu, and so on and so forth. But now imagine that we want to go from Porto to Coimbra, but we need to stop at Viseu. So how many kilometers do we need to drive? If we need to stop, if you want to go from Porto to Coimbra and you want to stop at Viseu, then you need to add up the numbers on the arrows. So we need to drive 127 kilometers from Porto to Viseu, and then we need to drive 93 kilometers from Viseu to Coimbra. Okay, and if we add 127 and 93, we get 220. All right, it makes sense. Now, suppose we want to make this road trip between Bragança and Lisboa, and we'll go from Bragança to Porto, Porto Viseu, Viseu Coimbra, Coimbra Porto Alegre, and Porto Alegre Lisboa. What list may represent this itinerary containing both the cities and the distances? That's the question. So how do we represent this itinerary, okay, with the cities and the distances between the cities? So we can use a list of pairs again and treat this as a graph. So we have an arrow from Bragança to Porto with number 210. Then we also have an arrow from Porto to Viseu with number 127. So that will give us the pair Porto Viseu 127. Okay, so the first component is the pair and the second component is the arrow. So this is like the example of the Instagram with the years that people started following one another. Okay, so we can use this list of pairs to represent this itinerary. And we are going to call it itinerary, okay? As I showed you before, so we are going to give a name to this graph, to this list of pairs, because it's a little boring to write everything every time we want to mention this list. So we are going to call it itinerary. And now our goal is to instruct the computer to calculate the total distance of the trip. So if we do this whole road trip, what distance will we travel? That's the question. So what will our strategy be? So we will start with the list of pairs, and then we want to do some sort of magic in order to get only the list with the distances. So we need a function, we need a transformation that will take us from list itinerary to the list with the numbers, with the distances. And then we want to add up all the numbers of that numeric list. And we already know how to do that, okay? We use the function sum. So what's important to understand and what we really need to do is to go from this list of pairs to the list with only the numbers in blue. How can we do that? We need to work with new functions, okay? So that's our goal. Our goal is to start with a list of pairs and get the numeric list with the distances between the cities. Now, as we have said, each element on the list itinerary has a pair, and the element before the main comma is the first component of the pair, whereas the element after the comma is the second component of the pair. So if we go on the computer and we ask and we want to know what the first component is, we use this function called FST. Okay, so FST abbreviates first. And if we want to know the second component, we write SND, which abbreviates second. So if I want the first component, I apply function first FST. And if I want the second component, I apply function second, which is SND. Okay, so the first component of this pair is Porto Viseu, and the second component of this pair is 127. Let's see if you understood this. So I will ask Luis to please launch this poll, and you will need to select.
Yeah, I'll need to select the right answers to each one of these.
Yeah, so there are 4 questions, and you need to select the right answers.
You have these 4 expressions, and so please select the right answer for each one of them.
Okay, so everybody got it right. Yay! So the first component of Porto Viseu is Porto, the second component is Viseu, then the first component of this one is Viseu Coimbra, and the second component is 93. So you all got it right, so I think this is understood, okay? So now to get the list with the distances, we need the computer to list all the second components of the pairs on the list itinerary. Does this make sense? Please pay attention.
It's now time for you to remember everything that we have presented here today.
Yeah, but please check that this makes sense in your head. So the list with the distances is precisely the list with the second components of each pair in the list itinerary, right? Because each pair in the itinerary has a number as the second component, which is the distance between the cities. So we know that if we apply function second to a pair, we get its second component. So we want to apply function second to all elements on the list itinerary, right? We want to go to each pair and apply function second. And what transformation allows us to do that? We have already learned that today. So a transformation that allows us to apply a function to every element of a list. That's the goal now. So I will ask Luis to please launch the poll and select the expression that allows us to get this list. Okay, we already have some answers. So we need to apply the map function, okay? Because second won't work, okay? Second operates with a list of pairs. But we want to operate with a list. Second operates with a pair, okay? You have a pair, you apply second. But we have a list of pairs, so we need to apply second to every element of the list. And for that, we use map, okay? So it's the expression map second. So final poll, final question for you before you can go and rest. So we need to sum. Okay, so we want you to write to tell us what is the complete computer program that allows us to reach our goal. Okay.
Yes, some of you already answered.
And we need to compose 2 functions. So we had this, right? So this is the list with the distances, and now we only need to sum. So we only need to apply function sum. And this is the complete program. So you see, in one line, we actually did everything. We went from this complicated list of pairs to the total distance, okay? And yeah, so see, this Haskell programming language is quite simple, and composing functions is very powerful. Okay, but by just applying 2 functions, we got what we wanted. I'm just gonna quickly show you this in the Jupyter notebook, okay? So I'm going to share another window.
You have just 5 minutes in it because we then need to share some links, okay?
I know. Okay, so you see this is the itinerary, and first we declare the names of the cities. Okay.
So by the way, just for you to understand, okay, so when we are talking there about a new data structure called cities that contains 6 elements, okay, so which are these cities that Portuguese cities that we are using here, okay? So we will not have time to explain you this, but this is precisely how we can create new data structures in Haskell, for instance.
Exactly. And now we have functions first and second, as we saw. Okay, so I won't lose time with this. And then if we ask the map second, we get the list with the distances, like super quickly. And then this is the complete program, and the answer is 829. Okay, so I'm done. Okay, so if you have any question, please feel free to ask.
Yeah. So we'll be waiting for your questions, and meanwhile, I will share with you in the chat two links. Okay, this first one is a questionnaire that we would like to ask you to fill with your feedback on this session today. Okay, and the second one that I will share with all of you is the very interesting course in Haskell that in fact is written in Jupyter Notebook, and so you can use precisely the same platform that Inez has been using to show you all these exercises. You can use this link to follow all the guidelines and everything that is available in a book, but on this case you have all these ingredients and all these contents available in Jupyter Notebooks that you can execute at the same time you are reading the materials. Okay. Oh, yeah. So I find yes, as we told you, we are applying this, and we are everything that you have seen here today are materials and contents that we are using in our classes, and in fact we are talking about kids and students between the 9 and 12 years old, as we have said in the beginning of this session. Yeah. But the most important thing is that in fact we, as we have seen in the last session, last webinar, we are trying to put all these concepts in the heads of our students in early stages. Okay, so we start playing with these things in the first cycle, okay, in a very implicit way, okay, subliminary way, and only then in grade 3 and behind, we apply these semi-plugged classes, and we use these semi-plugged classes. Then we go with them for the lab, and we apply these plugged sessions. Okay, always with Haskell, always with Jupyter, and in fact, this is becoming very successful in terms of what we are trying to do with our students. Yeah. Well, thank you, Miss Carter. Thank you, Christina. Thank you,
Yeah,
Paul.
thank you all.
And we'll see you soon, probably in the next webinar. Don't forget, Thursday, not Wednesday. Okay, so it's May 11. And I hope to see you soon. And please feel free to contact us at any time. Okay.
Yeah, we are
Obrigado, Eduardo,
always
também.
here for you. Thank you so much. Goodbye.
Thank you. Bye bye. See you.